Hello, my name is Noah Druss, and my project was on COVID-19 data analysis using linear regression, which is a machine learning method that creates a best fit line to predict data along a continuous spectrum. So as a short introduction, the main purpose of this project is to answer the research questions below, which are: 1. Can multiple linear regression find coefficients for each feature provided? How accurately can COVID-19 deaths be predicted from given infection data with simple linear regression and with polynomial regression? 3. How significantly will these models' performance change on a country level versus a global level? And finally, can we use different analysis methods to elicit patterns from the data? So as materials and methods really quick, the data set that I used was a 60,000 line and more updated daily CSV file with over 50 features from Johns Hopkins University's data repository for COVID-19. And the methods that I used in this study were simple linear regression, which is predicting a label based on one feature, multiple linear regression, predicting a label based on multiple features, and polynomial regression, predicting a label with a polynomial line of best fit as opposed to a linear line of best fit. So to answer my first research question, I was able to successfully find coefficients for each of the 9 features provided. So to answer my second and third research questions, I found that deaths could be predicted very accurately based on the number of infections, both at a country level and at a global level. At a country level, it was much more accurate, and using polynomial regression at a country level, it was even more accurate. It was incredibly accurate at that level. So for my final research question, I ended up finding that each of these 4 features, GDP, stringency index, which is how strict a country is in terms of lockdowns, median age, and life expectancy are all negatively correlated with infection rate, and that's with the Asian countries as outliers. So finally, for a few future directions for this project, this type of data analysis could be used either for a future pandemic to help curb it, or for similar infectious diseases like the flu maybe, that aren't as extreme as COVID but have similar numbers. Also, analyzing more features and different features could help a lot in determining which features are the most important. So finally, I'd want to acknowledge Dr. Aladhari, my machine learning professor, for helping out a lot and inspiring me with this project. And if you have any further questions, feel free to ask me during the Q&A session. Thank you very much.